Can you hear me?
Yes, sir.
Yes, sir.
I'm unable to get my slides back. Let me see. Do I have to close this?
Slides were not visible, right?
Are you able to see it now?
Yes, sir.
No, no.
Yes.
Slides.
Yes,
Okay,
sir.
wait. Thank you,
Okay.
thank you.
So না এটা আরো কয়েকজন জয়েন করলো, তারপর এটা আসছিল না আর কি। ওটা আবার মিনিমাইজ করে আবার এটা খুলতে হবে। না, এখন এলো আবার। মানে আবার যদি অ্যাড করতে হয় ওটাকে আবার খুলতে হবে। ওটা দুবার খোলা হয়ে গেল তো আমার। এই ফাইলটা দুবার খুলেছি। এটা কি করে আসছিল আমি বুঝতে পারছিলাম না। এখানে ক্লিক করলে আসে নাকি? একটা বন্ধ করে দেবো? ঠিক আছে। Okay, now are the slides visible? Hello?
Yes, sir.
Yes, sir, it's visible.
Okay.
Yes, sir.
All right. So the shaft is attached to the spinning rotor and power flows to and from the rotor through the shaft. Okay, so let me explain what this means. So in the case of a compressor, you will have an electric motor which will rotate the shaft. Okay. So power will flow, there will be a conversion of energy, electrical energy to mechanical energy of the shaft. Okay, and from the shaft, when the shaft rotates, it will turn the rotor also, and the blades which are mounted on the rotor, they'll push the fluid and convert the mechanical energy of the shaft to energy of the fluid. Okay, now look at the other case of a turbine. Okay, when the fluid is flowing over the rotor, it will exert forces on the blades and cause the blades to cause the impeller or whatever runner, the rotor to start rotating. And since the rotor is mounted on the shaft will also start spinning. And if you have an electric generator mounted on the same shaft, then you can generate electricity. Okay, so there is a flow of power to and from the rotor through the shaft. Okay, so when you have from the electric motor to the shaft to the rotor and to the fluid, or from the fluid to the rotor to the shaft and to the generator. Now, the rotor, which is mounted on the shaft, will be placed inside what you call a casing or shroud. So this is a metallic envelope which is pierced by the shaft and fluid carrying pipes. And the fluid will flow through the casing. Okay. Now, the turbine may also have some stationary elements or stationary members with what are called guide vanes, which direct the fluid. Okay, and in the stator there's no work done because there's no movement of the vanes, but there may be a change of pressure, either increase or decrease. Okay. Now you may have an open turbo machine where there's no outer housing. Okay. So an example is a wind turbine or a windmill, which you might see outside. Okay, so if you have a place where there's usually a wind at high speed blowing, okay, you can have a windmill or wind turbine. Okay, so this does not have a housing. Or you may have a propeller which is an axial flow device. It may operate without an outer housing. Or you may have unshorted fans, for example, the ceiling fan that you see. It does not have any cover on either side. It's open, and the fluid around the fan, it extends to the entire room. Now, as I said, you can classify the machines as impulse machines or reaction machines. Impulse machines are those in which the pressure of the fluid does not change as the fluid is flowing through the rotor. So here, it is the momentum of the fluid which will be changed, and the change in momentum will lead to a force being exerted on the blades. Okay. So it is called, due to the just change in momentum of the fluid, so it is called a pure impulse machine. Okay. Now, in a reaction machine, as the fluid flows through the rotor, the pressure will change. And the change in pressure will also be reflected in a energy transfer. Okay. Now, of course, here also there may be a change in the momentum. There is usually a change in the momentum. So, usually you will have machines where the kinetic energy of the fluid is changed and also the pressure is changed. Okay. So, you may have neither a reaction machine, pure reaction machine, nor a pure impulse machine, but a mixture. Okay. Now, you can also classify machines according to the direction of flow. So an axial flow turbo machine is one in which the path of the through flow between the passages of the rotor is wholly or mainly it's parallel to the axis of rotation. In the case of a radial flow turbo machine, the path of the through flow is wholly or mainly in a plane which is perpendicular to the axis. And in the case of the mixed flow machine, the velocity of the through flow at the rotor outlet has both radial and axial components present in significant amounts. Okay. All right. Now, any questions regarding this? If not, then I'll explain in more detail by opening another file. Okay. So these are some handwritten notes that I prepared more than 20 years ago. At that time, I was teaching at IIT Bombay. Okay. And I've already explained these things to you using the other slide. Okay. So here, I'm just talking about hydraulic machines which convert the energy held by fluid, which is water, into mechanical energy or vice versa. Okay. And turbines convert the fluid energy to mechanical energy. So you extract energy from the fluid. And as I said, we'll be talking about hydraulic turbines. Pelton wheel is an example of an impulse turbine. Francis turbine is a reaction turbine. Kaplan turbine is also a reaction turbine. And steam turbines, Professor P.K. Das may talk about.
Sir, the notes aren't visible.
Pardon?
So the notes aren't visible.
Okay. Now, this is a sketch of an axial flow machine. So this is your shaft. Okay. This is the rotor axis. And this is what you call the hub. Okay. And this is a section through the shaft and the.
Sir, they are still not visible.
Now, if you look at the other blades, of course, this is a very simplified figure. This
Sir,
is your
Sir, we
shaft.
can't see anything. Notes aren't visible.
Well, I am speaking near the microphone. Is it? Are you able to hear me now?
Sir, it's audible. We
Video is
can,
here.
it's not visible.
Pardon?
We can hear you. We can't see what you are
Okay.
saying.
So these are two views. Okay. So this is the shaft, and this is the radial blade. In this case, of course, they may be curved also. Okay.
Sir, slides are not visible.
So in this figure, it will rotate in this direction, so in a circular direction. Okay. And this is the other view where this is the shaft, and this arrow shows the direction of rotation. Okay.
Sir, you start presenting again. No one is presenting right now. So it's not visible.
So this is just a preliminary introduction. So this is the casing. Okay. So this is a sort of a sketch of an engineering drawing. All right. So this is hashed. That means this part is solid. Okay. And the arrow shows the direction of the fluid flow. Fluid will enter this way. Okay. And this is the shaft. This is a solid. This is the hub, which is a solid. Okay. And this arrow shows the direction of rotation of the shaft. And these are rotor blades which are fixed to the shaft hub. And these are stator blades which are fixed to the stationary part.
Sir,
So the stator blades will not rotate.
sir,
This is a multi-stage machine This is called the first stage. The second stage,
Sir,
each stage will have a set of rotor blades and a set of stator blades.
sir,
Yeah.
sir, the notes aren't visible, so you have to present it again. No one is presenting the screen, right? Or screen is not shared.
Which part do you want me to present again?
Sir, your screen is not shared. We can't see the notes. So you have to
The
present
slides.
again.
Huh?
Sir, your screen
Sir,
is
we
not
can only
visible.
hear you. Your
We
screen
cannot
is not
see the
visible
notes.
to us.
I'm now showing you figures. Okay.
So we
And
can't
I
show the
talked
figures.
about axial flow
We aren't
machines,
able
radial
to
flow.
see the figure.
Sir,
This is
notes
an
are not
example of radial
visible.
flow machine. Okay. So this is the shaft.
Screen stand off, sir.
Hmm?
Your screen sharing was turned off, sir.
So this is the machine. This is the section through the impeller. You have a shroud at front. Okay. And you have a shroud at the back. Okay. And this is the impeller passage. So fluid will enter, say water, axially. It will turn and go out radial. Okay. So if you look at this part of the section
Excuse
of
me,
the
sir.
rotor, this is solid. The hatch part is solid. This is
Sir,
the space in which fluid will flow. It will flow from radius r equal to r1 to radius r equal to
Sir, you
r2.
should click present now for presenting.
So this is called the heart
sir,
of the impeller, and these are the vanes. Okay. Anyway, I'll talk about it in more detail later on. So here we
sir.
see the
Excuse me, sir.
axially turning and going out radially. Yeah, I can hear you, but not very clearly.
Sir,
You want me to
sir,
present the previous set of things?
sir. Wait a second, sir. Sir, if you are using the projector, you need to rotate the camera.
Are you able to see this figure?
No, sir, we can't.
Sir,
No,
if
sir,
you are
we
No,
can't.
sir. No, sir.
All right. Are you
So
able to
only
see
the
now?
blackboard is visible.
I can use the blackboard, but then I have to call him and ask him to.
Sir, you have the camera right. Just rotate.
What I do tomorrow? Okay, or in the next class. Are you able to see these figures?
No, sir.
No, sir.
No,
No,
sir.
sir. No, sir.
No, sir. No, sir.
Huh?
Some files No, are sir. there. No, no, they
They're
are
not
not.
present.
They're not
Sir,
visible.
the presentation
Cannot
mode
see
is turned
figures.
off, so we can't see anything on your screen.
Sir, you should click present now.
Sir, there's an option of present now in the bottom right corner.
So this is the figure of a typical pump. All right. So here the fluid will enter this way. Ah, go
Sir,
out radial.
are you using the projector?
Which one? This one.
Sir, are you using the projector? Present.
See, are you able to read what
Sir,
I've written
please call the
here?
technical guy.
Oh, okay. So it is not being shared. I see.
So there's a option on the bottom right corner of the screen for presentation.
Excuse me, sir. Can you hear us?
The গোলমাল হচ্ছিল আবার। Is it visible now?
Yes, sir. We can see it now.
Yes, sir. Now it is
sir.
visible.
Is it visible now?
Yes.
Yes, sir. We can see it.
Okay. So this is the an example of the axial flow machine. Are you able to see this figure?
Yes, sir. Yes, sir.
Yes,
Very
we can.
Okay. See, I'm doing it for the first time, not very familiar with how to use it. Okay. So I've now shared the entire screen. So this is a figure of an axial flow machine. So you see this is the shaft, and this arrow shows the direction of rotation of the shaft. And this is the rotor axis, and this is the hub, which is the solid. And these are your solid rotor blades, which are mounted on the hub. Okay. And this is the casing. This hash is a section through the machine. So this part is the stator, and there are some blades here which are called stator blades because they're static. Okay, and they guide the fluid. They change the direction of the fluid. So this is what we call a multi-stage machine. So this each stage has a set of rotor blades followed by a set of rotor blades followed by stator blades. Then again rotor blades followed by stator blades. So I have shown in this figure 2 stages. So fluid will enter this way. The arrows show the direction of the flow. Okay. And this is the other view. This is your hub. Okay. And here I have shown the radial blades, but they could be curved also. So in these are 2 views of an engineering drawing drawn loosely. Okay. So as you see, the fluid is entering axially, and when it is flowing in the passage, there may be a radial component, and of course there will be a tangential component or swirl component because of the rotation. Okay. But the predominant relative to the rotor, okay, the rotor is rotating. So if you look at the picture relative to the rotating thing, if you have an observer on the shaft which is rotating, you will see the predominant direction of flow is axial. Okay. So this is a rotor, this is a stator. This together forms one stage. Then again you have a rotor followed by a stator. You can have 3 stage, 4 stage, whatever it is. Okay. Now, here is the sketch of a what you may call a radial flow machine. Okay. So this is a centrifugal pump. So you have a rotor. This is a section through the impeller. So there is a front shroud which is stationary, and you have a back shroud. Okay. And here the fluid will enter axially through what is called the eye of the impeller. Okay. And it will be forced to turn. So here the fluid flow is parallel to the axis. So you have an axial component of velocity, and the radial component is 0 at the entry. Here it will acquire a radial component, and there will also be an axial component, and then it will turn. And if I say this is radius, if I measure radius from the center here, this is R equal to R1, and this is R equal to R2. Okay. So from R equal to R1 to R equal to R2, the direction of the flow relative to the rotor is just radially outwards. Okay. So that is why you call it a radial flow machine, but it's not that the flow is everywhere radial. It will enter axially. So here the radial component of velocity is 0. And here in this passage and at the exit, the axial component is 0. Okay, and in between it will turn, so there will be an axial as well as a radial component. Okay, but this is a small region, so you don't call it a mixed flow region. Okay, it is a predominantly a radial flow machine. And here it is a predominantly axial flow machine. Okay. Now, so a Francis turbine and a centrifugal pump will have something similar to this, radial flow machines. In the case of a Francis turbine, the fluid will flow from a larger radius to an inner radius. Okay, so it will flow this way, from the larger radius to a smaller radius. And in the case of the centrifugal pump, it flows outwards from the inner radius to the outer radius. And here this is a sketch of a mixed flow machine where the fluid is entering axially and going out this way. So when it's moving through, these are the stator vanes and these are the rotor vanes. So this is your hub. Okay. So as you see here, if you look at the arrows which indicate the direction of the velocity vectors, it is like this. Okay. So it will have a axial component as well as a radial component, and the two will be of same order of magnitude. Okay, so I use this other file, other document to show you sketches here. Okay, the other material which is here, I have already typed in. Okay, so I'll mail these two files to you or share it somehow. So it's possible that in the next class, we'll use Microsoft Teams. But Professor Pikeda suggested that in the first class we use Google Meet. Okay. Now,
Sir, excuse me, sir.
yeah.
Hello. Yeah. So, sir, which textbook is there for this course? Hello. Hello.
Are the figures visible to you now?
Yes. So,
Yes, sir.
Okay, so these are some scanned figures. Okay. So this is the rotodynamic pump. So this is the eye of the impeller. So fluid will enter in a direction perpendicular to the plane of the paper. Okay. And this is the rotor which will rotate. So the fluid will enter in the axial direction, that is in a direction perpendicular to the plane of the screen. Okay. And it will, relative to the rotor, it will move through this passage. Okay. It will go out, and this is a volute casing. Okay. So fluid will be collected in the casing and will go out this way. Excuse me. Now this is the other view. So this is the shaft. So you'll have an electric motor which will rotate the shaft. Okay. And this is the shroud. This is a back shroud and this is the front shroud. And the whole thing will be immersed in water. So the water will enter. This is the eye of the impeller. It will enter axially. It will turn and go out radially. Okay. And it will be collected in this scroll casing or volute casing, whatever you call it. Okay. So this is an example of a volute type centrifugal pump. The next figure shows a diffuser type centrifugal pump. Okay. So here you just had the rotor and the fluid moved into the passage. Now here from the rotor it will move into stationary diffuser, and you have a diverging passage through which the fluid will flow, and when the liquid flows out through a diverging passage, due to the increase in area, the velocity will decrease and the pressure will increase by Bernoulli's principle. Okay, so the pressure rise will be higher. So this is called a diffuser type centrifugal pump. So this is another view of a pump. Okay, so in this figure you see the fluid will enter axially and it will turn and go out radially. So So this part and this part, this is the scroll tracing. It's not symmetric because, as you can see, the area is increasing here. So if you look at the distance from the axis to this point and from the axis to this point, they are not the same. Okay. Now this is a typical installation. Okay. So you have water in a reservoir. Let us say this inverted triangle means above we have air, and the pressure at this level is atmospheric pressure. Okay. So you have what is called a foot valve and a strainer. The strainer will filter out dirt. Okay. The foot valve ensures that water does not flow in the opposite direction. All right. So when the pump is running, the water will move from the reservoir upwards. Okay. Through this pipe and into the pump. Okay. And it will go out this way. And you have some check valves and gate valves, whatever it is. And this view shows the motor, the electric motor, which runs the shaft of the machine. This is a centrifugal pump and this is an axial flow pumps. So here you have a shaft and this is your hub. Okay. So the water will enter here and it will move in the passage here, primarily in the axial direction. So these are some views of the impeller. Okay. Now this is an example of this figure shows a Francis turbine. So this the principle is similar to that of the centrifugal pump, but as I said, in the pump, the fluid enters axially. That is, in this view, top view, here, top figure, it will enter in the direction perpendicular to the screen and move out radially. It will turn here and then move out radially. So the motion is from a smaller radius to an outer radius. So the fluid flows radially outwards. Now in the case of the Francis turbine, it will move radially inwards like this. Okay. And it will be directed through the guide vanes onto the impeller. So if you look at this view, the fluid will enter this way. Okay. It will turn and then go out this way. Okay. And it will be exit into could be a lake or whatever it is. Okay. So this water at the end is called tail race. Okay. And this is an example of what is called a axial flow or propeller turbine. Okay. So here again you see the water will enter this way. It will move through this casing. It will swirl. Then it will be guided through the stationary blades into the rotating element. Okay. So these are the blades. So if you look at this view, this is the runner or the rotating element. This is the blade. Okay. And these are the guide vanes. The fluid will enter radially, turn, and then move axially. So when it is passing through the rotor, it is in the axial direction. So this is a cut view, picture of the runner. Okay. So this is the hub, and these are the blades. So these are propeller type turbine. Now, some of you have done experiments in the hydraulics lab on the Pelton wheel. Okay. So these are the buckets of the wheel. So there you have a disc, and this disc is mounted on a shaft. And at the edge of the disc, you have this kind of buckets. Okay. So there are two buckets which are symmetrically placed. Okay. And water will impinge on these buckets, and it will be forced to move in a curved path. And the change in momentum of the fluid will impart a force on the blades. Okay, so today I just gave you an overview. From the next class, we will start analyzing in more detail. Now, any questions? I can go back to the previous two. Today I opened 3 documents. Okay, I am now in the 3rd document. If you have any questions, you can look at this and tell me. All right.
Hello, sir.
You have a.
Yeah, what would be the reference book for this course?
Pardon?
Reference book for this course? Hello?
Yeah, your voice is not clear. He's trying to adjust the decibel.
So can you hear me now?
Yeah. Now I can hear you.
Reference book for this course.
Reference books.
Ah,
Well, you can refer to standard books on fluid mechanics. Any undergraduate book on fluid mechanics will have a chapter on fluid
fluid machines.
machinery.
Yeah.
Okay,
Hmm.
but enough details may not be there. Okay. Now, my lecture notes are drawn from various sources. So you may not get it
Yes,
in
sir.
one particular book. I can send a list of references to you, but what I suggest is I'll mail some material to you, and I'll from next class onwards I'll use the blackboard. Okay, I'm going to draw some figures, and I am now speaking from a classroom in Nalanda. Luckily, a
Yes.
classroom has been
Hmm.
allotted to the course as the number of students is large, and they have a camera which will be focused on the board. If there are any teething problems, you let me know if you're not able to see the figures. So I suggest that you look at the figures and try to understand what is happening. So
Yeah.
I'll start from first principles. Okay.
Hmm.
I will try to develop the subject matter, the analysis from first principles in a logical way. Okay.
Yes, sir.
But assuming, of course, that you have some knowledge of
Fluid
your
mechanics.
first,
Yeah.
second mechanics. Okay.
Yes, sir.
And I'll give you assignments. You can work out the problems in the assignments. Okay.